Let's take a look at how to write an abbreviated electron configuration, and then also the difference between valence electrons and kernel electrons. So here we have an electron configuration for sulfur. It is in the P section of row 3, and so we write all of the electrons out until 3p4. And that gives us a total of 16 electrons. And if you add up the superscripts of your electron configuration, it will add up to equal 16. Now, it turns out that only the outermost electrons are responsible for chemical reactions and bonding. So those are the ones that are important. The other ones we don't really need to list so much because they're not really involved. So what we do is we think about breaking this into two separate sections. The highest occupied energy level, in other words, energy level 3 for sulfur. There's energy level 1, 2, and 3. 3 is the highest occupied energy level that has orbitals or electrons in the orbitals. So we will call that the valence level. And the electrons in here, those 6 electrons, are called valence electrons. The ones that are not in the outermost energy level, the inner orbitals that get filled, we call the kernel. Kind of like the core or the inside, we just use the word kernel to refer to it. So what we do is use an element symbol to represent the kernel, and then we write out the valence because that's the part that we actually want to see. So the way we decide how to do this is we look at what element represents all of these electrons. So if you look at 1s2, 2s2, 2p6, that's a total of 10. If we come to our periodic table and find the element that has 10 electrons, it's neon. Notice that it's the last element in the row before sulfur. So we will always, when we write an abbreviated electron configuration, pick an element from column 18, a noble gas, and put it in square brackets. Wherever your element is, look in the previous row for that noble gas. So when I write an abbreviated electron configuration for sulfur, I am going to put neon first in square brackets. And that's going to represent the entire kernel. In other words, all of this stuff all the way up to neon. And then I just write out the row that sulfur lives in on the periodic table because those are the valence electrons, the outermost electrons. So I can add to that 3s2, 3p4. And there's an abbreviated electron configuration for sulfur. Now, if I were to give you this abbreviated configuration and ask you what element it is, you couldn't just add up the 4 and the 2 and get 6. You also have to add the number for neon, which is 10. So 10 plus 2 plus 4 makes 16. And then you could look up element 16 and see that it's sulfur. So that's how you do an abbreviated electron configuration. The valence is the highest energy level that has electrons in it. So if we do something crazy like, I don't want to go too crazy. Let's do selenium. We know that that is going to end in 4p4. So if I write out the electron configuration, we can abbreviate that as well. So here is the outermost energy level. Here is all of the inner ones. So this is the kernel, and this is the valence. So now I need to look for selenium on the periodic table, which is right here. And so I go to the last element in the row before it. So here's the row before it, and the last element is argon. So I will put argon in square brackets. and then write out the row that selenium lives in, which is in row 4. That's the valence electrons, the outermost electrons. So it will look like this. And there's the abbreviated electron configuration for selenium.